So now what we're going to do is we're going to take this concept that takes all this low-level routers and Ethernet and fiber optic and simplifies all that down to this one thing called a socket. We make a socket and then we connect the socket to a far-end application. But then the problem is, what do we do to talk to that application? And so we just got done talking about how the transport layer talks back and forth, and we can open this connection between our application. Remember that this side is our computer and this side is the server computer, and we're going to pretend that all this complexity doesn't exist, and we've made a socket connection. And that is what we just got done talking about. But then the question becomes, what we're really interested in is not actually just making sockets, but doing something useful like web browsing. Web browsing to a web server. And then the question is, now that we have a connection, what do we say? That's really what this is. Our next problem to solve is, what do we say? So the most common protocol that we run across these days is a protocol called HTTP, which stands for Hypertext Transport Layer Protocol. And it's really the most dominant application layer protocol on the internet. It is how we retrieve HTML documents, but it also does web services like API stuff, and we'll talk to those things as well. And part of its success is its simplicity. It's so simple that I can explain it to you in like 20 minutes, and you can actually hack it yourself within 20 minutes. So we take this socket, this ability to call, and you basically say, I'm going to make a connection, and I'm going to ask for a document, and then wait, and you'll send me the document, and we'll disconnect. So it's a very simple protocol that has a whole ton of subtlety to it, but at its core, it's very simple, and that means we can use it to do lots and lots of things. And it's just the set of rules that tell browsers what they are supposed to talk when they're talking to servers. What are they supposed to say? Who talks first is one of the biggest questions of one of these protocols. So a protocol is just a set of rules of the road, right? Do we drive on the right side of the road or do we drive on the left side of the road? In driving and in protocols, it kind of doesn't matter as long as we agree, just so that we don't bump into each other. And like I said, one of the first things that you got to figure out in a protocol is who's going to wait for the other to talk and who's going to talk first. If you're both waiting for the other person to talk, then nothing good happens and you can't get started. So you have to start. So if you look at HTML, and we look at sort of what our web browser has in its location bar. Who knows, someday or in the future they won't even show us location bars. But this is what's called a URL, or a Uniform Resource Locator. And if you watch the video that I have of Robert Cailliau, you will see that he says, and I agree, that one of the critical things that the web did was created the Uniform Resource Locator. And the Uniform Resource Locator, before that, I mean, it's a simple concept, but before that, we had to know what kind of host to talk to, what kind of service to talk to, and what kind of application protocol, and what kind of document. And so if you take a look at your typical URL, like this YouTube URL, it's broken into what protocol are we going to use to talk to the server. This is the Hypertext Transport Protocol. What host are we going to talk to? And then what document are we going to get? So we're going to connect to this host and use the HTTP protocol to request this document. Okay? And you can see the same thing. We're going to talk to YouTube, a host named youtube.com, and this is the document that we're asking to get. Okay? And so that's how these URLs work. They have a protocol, a host, and a document. And again, a simple concept, but as long as everyone does it the same thing, things work out quite well. If you look at the specs for the URL, they're actually somewhat complex, but in the basic thing. So if we think about the act of surfing on the web, you've got some page that you're looking at, and then you've got these little hot links on that page, and you click something, and then you get a new page. This is what we call the request-response cycle. So let me show you that in a web browser. Okay, so let's find myself my web browser. Okay, here's a happy little web page, right? Here's a URL, drchuck.com/page1.htm. And so it's a rather nondescript web page. The only thing that you can do is go to a different page. So right now, this web browser is not talking to any web server at all. And at some point, I hover over this little link and I say, oh, I would like to get this other page. And so I click the button. And when I click the button, that tells the browser to go retrieve a different page. And if you look down here in the lower tiny left-hand corner, down here, let me go back to it now. If you hover down there in the corner, you can see which page it's going to go to. Okay, so when I click, the browser says, "Oh, the user, me, needs a different page," and so it then makes a socket connection and retrieves that page and shows the page. Now, this is all happening at the moment I press click. Click. Okay, that's a different page, and I'm looking, reading my page. I'm going to click on something else, and it's going to go somewhere else. Okay, so that's called the request-response cycle, because at the moment you click, it makes a request. The other page that it gets is the response, the request-response cycle. Okay, so request-response cycle, you are asking for a new document. So this is how it works, all right? You're going to hover over top of that first link. You click on the link. That click is an event that goes to a piece of software running on your computer called the browser. Could be Chrome or Mozilla or whatever, Firefox. And then the browser makes a network connection to the web server. The web server is a different computer, and it makes a connection on port 80 because it's like we're going to talk the web. And then it sends the application request for a document, and that's the GET request. It sends this GET request. The web server goes la 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 and does all these other things. And then it sends us back a page that might have come off of a disk drive, it might have come off of a database, who knows how it made that. And it sends us back some HTML with less thans and greater thans. And the browser receives that back as the information and then shows it and formats it. Okay? And so this is the request-response cycle. This side is the request, and this side is the response. And then every time you click, it kind of goes and gets, retrieves, displays. Get, retrieve, display. Get, retrieve, display. Request, response, cycle. And that's what your browser does over and over and over again. Now, if you wanted to write a browser, you could go find the standard that would talk about how to send this data. These standards are often developed by an organization called the Internet Engineering Task Force, or IETF, and they're often called requests for comments. It's kind of ironic to name a standard that we've been using for years and years in RFC, or request for comments, but that's an irony on purpose that basically is saying none of these internet protocols are so set in stone that we could never imagine changing them. So these things, even though some of them are many years old, this particular one I'm looking at is the IP layer, right? And it's September 1981. Now, a lot of things have changed, and that's why they call them requests for comments. And so you can see these. They're all open standards. There's no charge to look at them. And you can go read the standard for IP, and you can go read the standard for TCP and HTTP and all these things if you really want to read it. So if we were to look at one of the protocols, this might even be obsolete by now, of this Hypertext Transport Protocol, the HTTP, and then we could read through it. And it's hundreds of pages long, and if we read down and farther and farther and farther, you read far enough, it would say, if you are a client, like a browser, that wants to send to a web server, what is the syntax of that, right? And so it basically tells you what the thing is supposed to look like. You read a little farther, and what it will tell you is that you're supposed to send a first three characters are capital G, capital E, capital T, followed by a space, followed by the page you're interested in, and there's a little bit about which protocol version you want to use. And so if you look at what goes on underneath, this is how it works. And you can actually, if you have the right software running on your system, you can hack HTTP as well. And so that's such an easy protocol that we can fake it. And Telnet is a command that was originally used to log into other computers, but because it's unencrypted, it generally is not used to do login anymore because we want to use a secure login. But some computers, I'm using a Macintosh, Linux has it. You may be able to download a Telnet for Windows. I don't know, you probably Google Telnet for Windows. But basically this is a command line, and I'm going to use this to hand talk the protocol. So let me show you how this works. Okay, here I'm in a command line. And so I am going to use the Telnet command, which is not a web protocol. Telnet simply makes a connection and then sends whatever characters I type at the keyboard across that socket. So I can say telnet www.dr-chuck.com, and I'm telling it that I want to connect to port 80. So I told you that port 80 was the port that we use to talk to web browsers. So now it's opening a socket and connecting to port 80, which is, I showed you a little while back how to do this exact same thing in Python. And now what's happening is it's waiting for me to talk. I might say, hello there. And I'm not talking the right protocol. I said this, I typed this hello there, and it blew up. And it's saying bad request, your browser sent a request the server could not understand, additionally a 404 was not found, blah, 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 blah. Okay, so that is something that you will not see this if you use a browser, because your browser won't be dumb enough to say hello there. Because if we read the specification, we know that the first thing you're supposed to type is get. So let me try this again. I'm going to again make a telnet to that web server. The web server got a request. It was just a badly formed request. And this time I'm going to do it right. I'm going to type capital G, capital E, capital T, get. And then the page I'm looking for, http://www.drchuck.com/page1.htm. I have to tell which protocol I want to use, HTTP 1.0. And you also see the IP address. Oh, I was too slow. I was too slow. It was mad. Okay, I'll do it faster next time. I'll just point out that this is the IP address. The domain name is www.drchuck.com, but the actual low-level phone number of drchuck.com, at least for today, it could change, is 198.150.251.66.43. And then within that server, we're talking to port 80, and that's how we talk to the web server. Okay, I'm going to put this little string in my cut and paste buffer so that I can type it faster so it doesn't blow up on me. Okay, that's bad. I didn't type it. So now I'm going to make my connection again, and I won't be so talkative this time. Now I type really fast, get, and then I hit enter, and then I hit enter again. And now I have talked properly to this web server, and it's given me good stuff. I typed this blank line, so you have to type get, and then you have to type enter twice, basically. And that's part of the protocol. You have to type get and enter twice. And then it gives me a set of headers, which are metadata about this document. And it says when we're doing this, and what server I'm talking to, and how much data I'm going to get back. I get 131 characters back. And then it gives me a blank line, again, part of the HTTP protocol. And then it gives me the actual content of the document I asked for. The first page, that's the HTML for that page, and then it closes the connection. I mentioned it opens a connection, sends a GET request, retrieves the data, and the connection gets closed. This is why the HTTP protocol is so delightfully simple. Okay? So that we just hacked into a web server. And you can try to do it in any web server. You'll notice, as this one did, if you type too slow, it's like, you must not really be a browser, you're running too slow. So they do attempt to defend themselves sometimes from you doing things and just typing them randomly. And if you're talking the secure protocols, I can't hack the secure protocols nearly as easily as the insecure protocols. Okay, so back to our talk. So that's it. That's the request response cycle done by hand with no web browser whatsoever. Now, interestingly, part of my obsession with the command line is that in the real world, most hacking is done by people who are very skilled with command line. And you can see an interesting scene that one of my former students helped write in the Matrix Reloaded, where they're actually doing hacking and they're doing it right in the command line. And this is sort of this use of a very accurate hacking scene is now, lots of movies now do accurate hacking instead. Now, this request response cycle, when you grab a whole page, it actually does it many, many times. And so the original HTML comes back, and then a CSS comes back, and there is a way in most browsers to turn on developer mode. So let me just show you how that works in a second. So here is, let's go to www.pythonlearn.com. So there's a page. It's got a lot of stuff on it. It's got some images, got these, that, and the other thing. And I'm going to show you what happens when you retrieve this page, but instead watch developer mode, view developer console, and I am going to turn on the network. So let me make this a little bigger so you see it better. So this is a debugger that most of you could turn on. And I'm going to actually look at the network, and I'll clear this all out. So I'm going to refresh this page, and you're going to see that it's making many request response cycles, right? So it actually pulled in the very first page, which is the HTML for the page. Then it pulled in CSS, and then it just kept doing more and more things to the point where it took a total of 20 requests. So it's more complex than the single request response cycle, but each of these things are another request response cycle. And you'll notice that sometimes your browser will spin or something while you're waiting for a page to load, and that's because it's got to go request response, request response. Oh, and I got to get this image file and the CSS file, et cetera, et cetera, et cetera. And so that's but they're all based on a request response cycle, which is that GET request. So that is the application protocol for HTTP. Open a socket, send a GET, send a new line, get back the document, display the document, and do that over and over again. So now that we sort of, all these, whenever I tell you about application protocols, it's always more complex than actually using it, okay? So up next, we're going to do something a little easier than understanding application protocols, and instead, let's just use an application protocol.